Hello, Mr. Fry's Algebra 1 class. I'm taking a look at your exponential growth and exponential decay assignment that you have here. The formula to remember is y equals a parentheses 1 plus the rate parentheses, and then you have to the exponent t, where a equals the initial value, r is the growth rate, and t is the time. You all did number one together. If you need to take a look at number one, this is listed in the completed notes, the filled in notes in Mr. Fry's Google Classroom for this class. I'm just going to walk you through these so maybe it helps you understand, and how to work these out a little bit better. That calculator's not working. So taking a look at the two on, even though we did these in class, but the cost of tuition at a college is $12,000 and is increasing at a rate of 6% each year. Use an exponential function to find the tuition cost after 4 years. So the initial value, A, is 12,000, and that is a comma there. The rate is, you just take 6% as a decimal only, and so you move the decimal over 2 places to the left, so it would be 0.06. And then you have the time. The time is 4 years. So you take and use this formula, and you put in the initial value, and the 1 plus the growth rate is just 1.06, and then you have the time as your exponent. And you would just plug this in your calculator as so. And I'm basically showing this to you to show you how to use your calculator. So 12,000, just like you see it, use the parentheses, 1.06, and then I use the up button, which is right here. That's called a caret, the up button, and it's to the 4th power, and then I hit equals. And so I have $15,149.72. I'm just going to round to the nearest cent. You would do the same thing here for number 3. The number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. Use an exponential function to find the number of student athletes after 5 years. So we start at 300, the rate is 0.08, and the time is 5. So I just plug that into my formula from the top of the page, and we would take 300, and then we have 1.08, use the caret, 5, and I get 440 and 79, that 8 makes it go up to 80, so 440, 80, the number of student athletes. Oh, so we're talking about people here. So we don't want to have like a partial person. That would not be good. So we're just going to always round down. So that would be 440 student athletes. Okay, so 440 student athletes. So for number 4, the annual sales for a company are $144,999 and are increasing at a rate of 6% per year. Use the exponential function to find the annual sales after 7 years. So, I have it set up for you, and I would like you to work out that problem. You just plug it in your calculator as so. And this is going to be money, so you could round that to the nearest cent. For number 5, population of a small town is 1,600 and is increasing at a rate of 3% per year. Use the exponential function to find the population of a town after 10 years. Once again, there's your A, R, and T. And you would just plug this in just the way you see it into your calculator in order to figure out the population. Now, you're going to round down because this is population. We're talking about people. So when you get to this answer, we can't have a partial person, so always round down when you're dealing with people. Number 6, in 1985, there were 285 cell phone subscribers in Mayville, and the number of subscribers increased by 75% per year after 1985. find the number of subscribers in 2008. Well, the really only thing you had to figure out was the difference between 1985 and 2008, which is 23 years. So that's going to be my exponent. It's going to be a large number because, yes, it did explode from 85 to 2008, and then even more now. So 285 is your initial, and 1 plus the 0.75 would be 1.75. So just plug that into your calculator the way you see it, and that should help you answer that question there. Then we have the decay. The only thing that's going to be different with the decay is that you're going to subtract the rate. So the rate's going to be less than 1. So we still have the initial value, and we call R now, instead of the growth rate, we call it the decay rate because we're subtracting, and the time. So taking a look at number 7, the population of a town is decreasing at a rate of 1% per year. In 2000, there were 13,000 people, or 1,300 people. Use an exponential function to find the population in 2008. So that was 8 years. The rate is 1%, so that moved the decimal over 2 places to the left, so it's 0.01. And the initial value is 1,300. When you multiply this out, you get 1,199. You got to round down to 1,199 people. Okay, number 8. I have number 8 set up here for you. The value of a car is $18,000 and depreciating at a rate of 12% per year. Use the exponential function to find the value of the car after 10 years. So we have the initial value, the decay rate, and the time in years. And we would just plug those in. That comma should not be there. It's just 1 minus the 0.12, which is actually 0.88. Just plug that into your calculator, and you should get $5,013.02. Okay, number 9. I want to work this one out with you. A farmer buys a tractor for $50,000. If the tractor depreciates 10% per year, use the exponential function to find the value of the tractor in 7 years. So we would just have our initial value, we have our decay rate, and we have our time. So I'm going to put 50,000, and I'm going to do 1 minus 0.1, or 0.10, it doesn't matter. I'll put 0.10 there. That's what I wrote, to the 7th power. So that tractor is going to be worth $23,914.85. That 5 rounds that 4 up to 5. So 23914.85, and that's money. So I'll make it look like money. I have number 10 set up for you. An investment of $8,200 loses value at a rate of 2% per year, and use an exponential function to find the value of the investment after 9 years. So you have the initial value, the decay rate, and the time. And so with that in mind, you are going to take that initial value and multiply that times by 1 minus the 0.02 to the 9th power. Put that in your calculator. Put this in your calculator just the way you see it, okay? And then you'll get the answer for what y equals, which would be money, and make it look like money. For number 11, I want to do this one all the way to the end with you. The initial value of a book is $58 and decreases at a rate of 7% per year. Use an exponential function to find the value of the book after 8 years. So we have the initial value, and we have the 0.07, which is the decay rate, and we have 8 years. That's the time. So with this one, I'm going to do 58, and then I have 1 minus 0.07, back parentheses, caret it up, that's the exponent, and you get $32.46. So $32.46. Make it look like money. And number 12, set that one up for you, and you could finish it up. The population of a town is decreasing at a rate of 2.5% per year. If the population in 2000 was 28,000, what is the expected population in 2015 if this rate of decrease continues? So you have the initial value, the decay rate, and the time, and so you would just plug this in. Now, it's population, so we're talking people, so round down when you get that answer. Okay? hopefully this helps, and good luck on the few that you guys are venturing off and finishing up on your own.